I keep telling people that the virtual reality is like just discovering fire, and we don't even know how to cook yet.
It gives you the sensation of actually experiencing the walkthrough or the fly-through.
Virtual reality is the ability to take three-dimensional engineering designs and translate those into visually interactive processes and programs.
Sometimes it's important to do things which you cannot do in reality.
You can actually simulate the surgical procedure. And that's being done now, for example, in complex facial anomalies, where children are born with congenital defects of the cranial bones, for example. And the surgeon can then create a virtual surgery and to plan out what the child will look after the reconstruction is performed.
I see virtual reality as a continuum, starting with elements as simple as flat screen stereo images that we view through shuttered glasses, all the way to fully immersive cave environments that you can walk into and be surrounded by the image, be surrounded by the sound. Somewhere in that continuum is the right business decision to make a cost-effective implementation of virtual reality for the business that we do. I'm not paid to conduct an academic exercise. I'm paid to make a profitable implementation of these tools.
And the whole idea of virtual reality is being there, and being there brings understanding, which is what we say. And it brings understanding because people can use their minds to see things, relationships they otherwise wouldn't have been able to see. It's all a way of just enhancing human cognition, which is what we started to try to do way back in the 60s.
In the 1960s, when computers became common in the workplace, the punch card, paper tape, and magnetic tape were the main input and output devices, or interfaces. In the late 1960s, we started using keyboards and printers, and in the 70s, we added monochrome monitors. These were followed by the mouse and laser printer popularized in the early 80s. Keyboard and mouse together let you operate a computer through a graphical user interface, which turned click and drag into household words. This was the new interface style designed for interacting with two-dimensional applications, such as word processing and spreadsheets. The mid-1980s brought vibrant, interactive, three-dimensional graphics and visual simulation of complex data. And the computer interface also evolved beyond keyboard, mouse, and monitor, allowing you to not just visualize data, but to experience data, much as you experience the physical world around you. Now, instead of typing in a set of coordinate axes to change your viewpoint, you just turn your head. Instead of tapping keys or squeezing the mouse to choose and move a 3D model, you just reach out and grab the object. You don't need to adapt to the computer interface because the computer interface is adapted to you. This interface style, known as virtual reality, has captured the world's imagination.
This is so cool.
On its most basic level, virtual reality is technology that gives you a more natural and direct path to your data. Because of that, it's an entirely new tool that helps solve business problems in an entirely new manner. Successful organizations always seek new ways to respond to their customers and carry on the spirit of innovation and leadership. These are the pioneering companies that have taken virtual reality out of the lab and now implement it as a power tool in a variety of ways.
One of the challenges that we've been given at the John Deere Industrial Equipment Division by our management is to reduce the amount of time it takes us to produce a vehicle. And one of the things that virtual reality has been able to provide us is the ability to produce fewer mock-ups, to produce hardware later in the process.
We're trying to join a team to go after a European airport. The team had already budgeted about $200,000 to do a physical model if they made the short list. We think that we can make that model more interactive, better quality, and more attractive to the people who are making the decision for a half to a quarter of that price. That's a significant difference. That's where virtual reality, once you've made the investment, can really save money on a project for customers.
Virtual reality helps us solve here at Chrysler problems involving ergonomics, the interaction of the customer with his vehicle, where we're able to review the styling of instrument panels and interiors early in the cycle and help us decide which are the the more pleasing appearances that we want to offer the customer in the future. We can visualize and render proposals and designs in a matter of a couple of hours, where previously it took us 2 to 3 months to build a property.
We can put a person inside a car now, sitting in a driver's seat, and they can basically experience many of the things a driver would experience. They can reach out and they can touch the dials, the radios, the controls, and they can also grasp the steering wheel. They can look around, and they can look outside to see what it would look like in a real vehicle.
You can achieve customer satisfaction by delivering great products at great prices. And virtual reality really enables us to do that. So it's really a tool.
Prototypes become a burden if you end up doing iterative change in iron. What we're trying to do is to interact in our design process at the beginning. We want to build equipment electronically. We want to evaluate it and analyze it electronically. We want to make changes at that point. The first thing that we were able to accomplish was to eliminate the need to do an industrial styling model, a foam core model of a machine. It was about a $40,000 or $50,000 expenditure. So that was our first payback, that was the first ringing of the cash register.
The auto industry and General Motors spend billions of dollars every year on physical models that we build and we throw away. They're made out of cardboard or clay. And the reason we do that largely is because the computer technology that's existed is too cumbersome and too intrusive for people to use to understand the models they used to make by hand. So when you look at these things in a CAD model, as a CAD model on a CRT, people don't understand it in the same way they understand a physical model that is a full-sized part sitting right in front of them. We found our designers, if you watch them, they move their heads in very subtle ways to look at the light play off of a model that they built, a full-size model. That's how they understand surfaces. And they're being asked by current technology to view a shaded model on a monitor and rotate that model on the screen but hold their head still. And this is very foreign to them. They'd rather be able to do what they naturally do. So in this sense, the computer's been in our way. But if we can take virtual reality technology, whose promise is to give us back those 3D environments that we've not had except in the physical world, then we can build these cars out of light, and then we don't see the computer getting in our way anymore.
We build plants for people, and clients have a hard time sometimes visualizing, conceptualizing what our idea is. I can take the client and I can bring him in, set the helmet on his head, and he can actually see what his plant is going to look like. He can walk through it. He can get a sense of size and space. He can walk into the new atrium and see what the view is looking out into the parking lot.
Here at McDonnell Douglas, we're using virtual reality initially to help us solve supportability problems earlier in the aircraft design so that we can get inputs in without building a hardware mock-up. And we've shown from a cost-benefit relationship that that's very cost-effective to do.
The first virtual reality systems were designed to teach pilots and astronauts how to fly. These flight simulators inspired the creation of driving simulators, designed to teach the skills necessary to drive trucks and trains. Now that the cost of virtual reality has come down while its performance has gone up, other organizations can use simulators to teach people the skills required to work in hazardous situations. Ford Motor Company, for example, which has developed many virtual reality solutions, recently developed the Vulcan Forge Hammer Operator Training Simulator.
Let me tell you about our operation at Vulcan. It's extremely demanding. It's a harsh operation. It can be dangerous at times. There's a close proximity of people working together with hot steel. And the hammer operator needs to be extremely proficient with respect to eye, foot, and hand coordination. Typically, the on-the-job training is anywhere from 6 months to 5 years to become a very proficient operator. And we really couldn't afford that. We needed a better tool to be able to do that. And that's where virtual reality came in.
When you're targeting training, one of the things that's most important is the realism of the environment. When the operator goes out to the plant floor, you want him to feel like he's already been there.
On the virtual reality system, it was fairly close to the actual hammer the weight, the rolling of the forging. All this was simulated real well, real well.
Board worked with the UAW, we worked with the die makers in the tool shop, and we worked with several different suppliers to develop this system. After the training period, we did a full-day evaluation on an actual hammer measuring scrap and throughput. And in both cases where we did the benchmark, our simulator-trained operators were outperforming 10 to 20% better than the guys who were training on the job for the same amount of time.
Not only is this a good tool for Vulcan, but throughout Ford Motor Company or throughout the manufacturing community, in any application which is a harsh job environment, it's a tremendous tool to be able to establish that feel in a safe environment before they go out to the actual workplace.
I feel that the simulator is a better tool to train on than training on an actual job, especially a high-risk job. Using a simulator, you're able to learn and make mistakes with no injury to yourself. Whereas on the actual job, if you make mistakes, then serious injury could occur. So I would say virtual reality is a great learning tool.
Virtual reality is a great learning tool because it helps communicate complex concepts through vivid images, spatial sounds, and physical forces.
Stop and think before you do what you're doing and lock it up.
Virtual reality itself can serve as a communications medium. A virtual reality setup can allow people in different places to enter the same virtual environment, where they both interact with the same virtual model simultaneously. They see the effects of each other's input, whether they're in the same room or miles apart.
The greater power of virtual reality is to be able to have different people located in different places interact within the model in a collaborative setting. We've already done this between San Francisco and London, and you're able to identify the people from the different offices being within the model and carrying out a design review in real live time.
Let me go back to when I first joined this company. We were in the habit of making presentations of projects to customers very far away. We would prepare a presentation, take it to Saudi Arabia, and deliver a 1 to 2 hour presentation. To do that, we needed to stop work 3 weeks before the presentation, prepare it in a very sophisticated package of graphics and models, ship them all, make the presentation, pack them up, and ship them back. Recently, we made a presentation between here and London using VR. We had 2 Onyxes connected by an ISDN line. We sent the model an hour before the presentation over the network, and we conducted the presentation with 2 people inside the model wearing avatars. It took a very short amount of time. We continued to work on the project all the way up until just before the presentation. We were able to absorb the decisions made and move ahead immediately. We're working with digital models now, not with physical models.
Halfway across the United States, McDonnell Douglas of St. Louis uses virtual reality to improve aircraft design and reduce the cost of building prototypes. The company evaluates the design of an aircraft engine by importing the engine bay and maintenance equipment models from a CAD/CAM system. Then engineers interact together in the same virtual environment to evaluate supportability, the ease with which workers can check clearances for installation and removal of equipment.
Getting multiple people in is really an important thing to do. Many supportability operations on an aircraft require multiple people, and we can simulate that well now. The things that we need to be able to do better are get the full body in and then be able to detect interferences between the body and the parts that this person is moving around in the virtual environment on very large models. A lot of people are still put off by the head mounts and all the cables, but it works very well having a conference room set up with an immersive setup where people can go and have meetings and discuss things immersed in the environment.
Critics have long complained that the computer culture has increased our isolation. Virtual reality puts an end to that isolation by promoting and enabling collaboration among people, even people with different skills and different objectives. The concept of a virtual reality conference room is capturing the imagination of creative engineers around the world, including those in Cambridge, England, the home of CAD Center, a leading developer in the area of process plant design.
In the old days, the plastic model allowed for group interaction. People could wander around it, peer at it. These groups of people, quite large groups of people, could come in and assess whether it was a workable design or not. When we moved to a digital model of the design, and it only appeared on relatively small screens, then that group interaction was lost. So what we've really pioneered here with all this equipment is group virtual reality. If you put a group of people working together and you get the right group teamwork environment, they are more effective as a design team than they would be as individuals, communicating somewhat remotely and somewhat impersonally via concurrent engineering devices that are coming up. They serve a purpose, but they don't do as well as actually having the people here, talking to each other, moving freely, no headsets, unencumbered, and you just get this fantastic team spirit building.
Virtual reality for us means a visual engineering centre, a group environment where engineers and designers can come together. One of the first projects that actually used a visual engineering centre was a major refit to an existing North Sea gas production platform. The critical things were really for the barge crew, for the crane crews, to understand their responsibilities and where they were expected to be at each stage of that installation. We're talking 5,000 tonnes of steel being lifted and being moved around and being welded into place with very, very heavy lifting gear floating out there on a fairly choppy sea, making sure that everybody was in the right place at the right time, really understanding their job, where the ships had to be, where the crane was at each stage. By getting the whole project team together, they're all looking at the same problem. They're all focused on the screen. It's not my problem, it's not your problem. It's the team's problem.
If y'all see anything that would cause problems, now's the time to solve it, because
the screen is so big that it can hold a whole real-world problem at one time. The whole team can focus on that and they can solve it and move on to the next thing. They estimate that by doing that, by using group virtual reality in that way, they save something of the order of £3 million just on this one project.
So let's make sure everybody's happy with the installation procedures. If y'all have any.
As these pioneers innovate new ways to build innovative products, they also keep in mind that this is just the beginning of the quest for natural, intuitive interaction with advanced 3D graphics. There are still challenges to overcome and goals to attain.
From the point of view of what we might do in applications, I think we haven't even scratched the surface, because virtual reality in an engineering sense is very much to do with putting people inside data so that they can use all their senses to interact with that data.
How do you tell when you've touched something? Especially when we're in something like the cave, where you feel you're fully immersed in the scene. How do we then put something on your hand that you still see as your hand, but then can interact with the scene? And how do we tell you you've interacted with it? Do we give you a little pulse back?
But I feel the skin. I can feel whether it's harder with bone and all.
I think this particular technology should be exposed to the universities where there are manufacturing curriculums, so those students know what is available.
There's a lot of people that think what we're doing is a lot of fun and toys for boys, but as we've progressed in the last couple of years, we've really proven that it's not just that, it's really valuable to the company. A lot of people in upper management have really agreed with what we've seen and are basically investing in the technology for the future.
Once people see it, they like it.
Really, everybody who's working in these industries should be using this kind of technology.
VR has such a potential use and applications all over our business.
We view technology as a discriminator. We're always going to be on the cutting edge of technology.
It makes us more competitive from a quality standpoint.
It's not a science project. It's an actual real-world application. There's some practical applications where virtual reality fits. And if we focus on those, you'll see a lot of success.
Bottom line, it's a good business approach.
People look at the way they are doing things today and look at what we are doing, and they see how they can change things. It opens up a whole new vision for them, and that's what I find most exciting about the technology.